All right, let's look at the homework 5.4, problem number 7. All right, it says that we need to use a graphing utility to graph the integrand and then determine if the value is either positive, negative, or 0. All right, so let's do that. All right, before we do the graphing utility, remember that we have this property. If you have an integral from negative a to positive a, f of x dx, right? This is equal to, right? One of them is simple, is actually 0 if f is odd. And then if f is even, then it's actually, you can do 2 times from 0 to a. So basically we take a half of it. The other side is going to have exactly the same value, so we can just multiply by 2. So if f is even. All right, so let's check this function f. I'm going to call this integrand f of x, which is x times square root of x squared plus 6. All right, so let's see if it's even or odd. So we plug in negative x into it. All right, so you put x is replaced by negative x. And inside the square root, we have negative x, but it's squared, plus 6. All right, so this is equal to negative x. All right, since negative x is squared, the negative sign will go away, so you have x squared plus 6. And you can see that this is just simply the negative of the original function, f of x, right? By definition, we know that f is an odd function. All right, so if you get the positive f of x, it's even. If you get negative f of x, it's gonna be odd. So in this case, it's an odd function. So answer is very easy. If you have an odd function from negative 12 to positive 12, it's going to be 0. All right, so why is that? All right, so let's sketch the picture. All right, so I'm gonna put f of x is equal to x times square root of, let's see, x times square root of x squared plus 6. Right? So the picture looks like this. Maybe I'm going to squish it a little bit here. Let's see if I can do it. Let's say squish it a little bit here. And since it's going from negative 12, so I'm going to squish it here. And maybe I have to even squish even more. Let's see if I can do this. All right, so we have that. All right, so integral is going to look like this. Let's see. All right, so integral of a function f going from negative 12 to positive 12. So it's going to look like that. All right. So as you can see, you have a region which looks like it's a symmetric and has the same size, sort of. All right, so you have so region above the x-axis. This counts as a positive, and you have a same magnitude, but this part is going to count as negative. So they actually cancel each other out, so that the integral is going to come out to be 0. All right, so let's type it in. All right, answer is going to be 0. All right, let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.